Hello everyone. In this video, we are going to see a question that is based on AC transient. Okay, so you need to find out the time instant at which you are opening this switch S1 and you are closing the switch S2 such that the current that is coming from this AC source is transient free. You need to find out the time instant at which you need to perform switching actions such that this current I of t is transient free. So before I explain, I should explain uh, the AC transient phenomena. Why does this AC transient comes into picture? So let's say you have one voltage source here. I'm taking one example, and let's say voltage source is Vm sine omega t plus theta. Okay, and let's say you have this resistance and inductive load R and L. If you close the switch, what will happen to this current? The nature of the current. See, the moment you are closing the switch, this current will have two component. One is AC component, one is steady state component, and another is called transient component. Okay, so I of t will have two component, I transient and I steady state of t. Generally, when you write the current of inductor is lagging by 90 degree with respect to the voltage across the inductor, you can say. So that is something that is valid for steady state, not in transient period. And let's say you had only this R and L circuit and the same voltage source, and this circuit is operating at steady state, then in that case your steady state component of current or steady state current will be Vm by mod Z sine omega t minus theta plus theta minus theta z. Okay, and this is R and this is j omega L. Okay, here Z is equals to R plus j omega L, and mod Z is equals to R square plus omega L square, and theta Z is equals to impedance angle tan inverse omega L by R. Okay, this is the thing, and this particular relationship valid at steady state only. Okay, but the moment you are performing some switching actions and inductor doesn't allow sudden change of current, so we have to consider that also in the analysis. So steady state current says this should be my current. Okay, but since my inductor was relaxed before switching action, so inductor will say I had zero current before switching action, so I must have zero current after switching actions. So let's say I perform switching instant at t equal to 0 second, let's say. In that case, the steady state current is saying Vm by mod Z sine theta minus theta z. This is the steady state current. If you just see steady state component of current at 0 second, if you perform switching action at 0, this is the current the circuit is demanding. But at the same time, my inductor says I will not allow any sudden change of current. So I have to nullify this current such that the inductor current can be continuous. So for that, there will be a transient current in the circuit. That transient current will be in such a way that it can nullify this current. So Vm, that should be Vm by mod Z sine theta minus theta z. Okay, this will be your magnitude and it will be decaying in nature, e to the power minus t by tau. Okay, that tau is depends on the R and L. Okay, this is the transient component, and if you write the total current I of t is equals to the transient current and steady state current minus Vm by mod Z sine theta minus theta z e to the power minus t by tau plus Vm by mod Z sine omega t plus theta minus theta z. If you put t equal to 0 in this equation, you will see at t equal to 0, your I of t is simply 0. That is actually something inductor demanding. Because of inductor only, this particular extra decaying DC component will come into picture. That is something we call transient component. Okay, and in the question it is asking at what time I perform the switching action such that this component can be this component will be entirely zero. So from this particular analysis, you perform switching action at t equal to 0, So can you just tell me at what time you should perform the switching action such that you will not get any kind of transient? So for that, what you will have to do? Uh, that means this particular quantity has to be zero. That means theta, if you perform switching action equal to zero, sorry, if you perform switching in let's say you perform switching action at any time instant. This is valid for t equal to zero only. But let's say I perform the switching action at any given time t equal to t naught. T equal to t naught. In that case, your steady state component of current says Vm by mod z sine omega t naught plus theta minus theta z. This is something the steady state current is demanding. But my transient current should flow because inductor current is zero before t equal to t naught. So the total current should be I of t is equals to I steady state t. Sorry, I transient I should write first plus I steady state of t. I transient should be minus Vm by mod z sine omega t naught plus theta minus theta z into the minus t by tau. Here it will be t minus t naught basically. T minus t naught by tau because the entire signal got shifted. So again Vm by mod z sine omega t plus theta minus theta z. Now in this equation, if you put t equal to 0 in this equation, you see this particular term will vanish. It will be 1, and you will be having just, if you just put t equal to 0 at t equal to t naught, from this particular equation I of t naught you will get minus Vm by mod z sine omega t naught plus theta minus theta z. This is 1 plus Vm by mod z sine omega t naught plus theta minus theta z. See, this particular term is getting cancelled, so I of t naught is simply 0. So inductor current is continuous. So in this question, it is asking at what time you should perform the switching action such that the transient component can be 0. Basically, you had two source at basically before t equal to t naught, your this particular circuit was acting, and this was at steady state 5 volt 1 ohm. And at steady state, if there is an inductor simply behave as a short circuit. So this inductor will simply behave as a short circuit. The total current that is flowing in the circuit is I of infinity, I should say, 5 by 1. So 5 ampere current was flowing in this inductor. So in initial inductor current, so before, so I should say at t equal to t naught minus, just before the switching action, the IL is simply 5 ampere. Now I should perform, or I should close the switch S2 at time at t equal to t naught such that this I of t current is transient free. So if I draw the time axis, this is t and I of t. Let's say this is my t naught. Just I'm saying this is my t naught, and before that inductor IL current, inductor current was simply, it was 5 ampere. Now I should not disturb, I should perform switching actions such that my inductor current at t equal to t naught plus also start from this 5 ampere only. Then only I should say there is no transient. Okay, because maybe I can explain some another way. Hmm. Here, let's say. So my initial inductor current T naught 5 ampere. Now this is my resistance, inductor, switch. This is my voltage source. Voltage source is 10 sine t plus 30. Right? T plus 30 degree. T plus 30 degree. 1 ohm only. You should open the switch. You should, sorry, you should close the switch at t equal to t naught. If you just neglect this 5 ampere and at all, and if you just look into this particular circuit, how the circuit will behave at a steady state. Like this is the circuit you have. At steady state, the voltage is sinusoidal. So current will also be sinusoidal in nature, right? At steady state, I'm saying at steady state, current will also be sinusoidal in nature. But the thing is, my initial inductor current was the initial inductor current was 5 ampere till this, let's say this instant t naught. This instant, my initial current was 5 ampere. So my at steady state, like I should get the time instant such that if the at steady state the current is sinusoidal, from here also current should start like sinusoidal, like it may be like from here only it will start taking a nature of sinusoidal. Okay, it will not draw any kind of decaying exponential current or transient current. See, if you see from this point of time, you can see, you can observe it is a purely sine wave, s- sinusoidal in nature. Okay. So how to do that? So maybe I can perform I can calculate the steady state current. Is of t is equals to 10 by 1 plus j1 sine t plus 30 degree. So 10 by root 2 sine t plus 30 minus 45 degree. Okay. So 10 by root 2 sine t minus 15 degree. This is my steady state current. Okay. Now, let's say I performing switching action at t equal to t naught. So at t equal to t naught, my current I is steady state of t naught is equals to 10 by root 2 sine t naught minus 15. Okay, sine t naught minus 15. This is the current that is demanding, that is at turns at you can say at t equal to t naught. But at the same time, this current, if anyhow this particular current becomes equal to 5 ampere, then there will not be any kind of a transient, right? So I should equate 10 by root 2 sine t naught minus 15 is equals to 5 ampere. So what I will get? I'll get as 5 root 2 by 10 sine inverse answer. So I'm getting t minus 15 degree is equals to 45 degree is equal to uh, 60 degree. It is degree, and omega is equals to 1 here. Omega is equal to 1 radian per second. So this degree I can convert into radian per second. Pi by 180. So pi by 3 radian per second. Sorry, pi by 3 second actually. Sorry, pi by 3 second. So that means if I draw here, let's say this is my pi by 3 seconds. Maybe I can draw the voltage equations and current equations, then it will be much more clear to you what is happening basically. So this is my t, and here omega is equals to 1. Okay, because sine, because if you see the equation, omega is equals to 1 in voltage source. So the voltage is somewhat uh, leading by 30 degree, right? 30 degree. So at t equal to 0, it has, w- for this particular equation, voltage equation, Vs of t is equals to 10 sine t plus 30 degree. Now at t equal to 0, it has 5 5 value, 30 degree to lead. So this is how your voltage source is. Okay, this is how your voltage source is. This is your Vs of t. Okay, and this is your pi by 6 minus pi by 6 0, and this is your, this total duration is 180 degree, right? So if it is theta plus pi by 6 is equals to pi. So theta is equals to pi minus pi by 6, 5 pi by 6. It will be 5 pi by 6. So this value is 5 pi by 6. Okay. And if I talk about the current, the inductor current, let's say 5 into pi by 5, 5 pi by 6 actually, 5 pi by 6 is simply 2.617, and pi by 3 is simply pi by 3 is equals to 1.047. So somewhere here, let's say it is 1.07, this pi by 3, I can use this color, pi by 3. So this from before pi by 3 it was 5 ampere, and still after pi by 3 plus also it will be 5 ampere. But now the current waveform expression, since the transient current will simply vanish, you will have this particular current waveform, 5t minus sine 10 by root 2 sine t minus 15. So your current equation is 10 by root 2 sine t minus 15 degree. So 15 degree means pi by 6 it is basically 60 degree, and it is minus 50 degree lagging. So at t equal to 15 it will have 0. At omega t equal to 15 equal to 0. That means here it will be 0. So then it will start. Okay. So like here it will start like this dotted line, then okay, like that it will, the current will flow. Okay. So now you can see it is a continuous line. So this is how your current will flow, and there will not be any kind of transient. Okay. Like from here only it will start uh, taking the sinusoidal, pure sinusoidal waveform. Okay. Then there is no transient. Before, what is happening? Before, there was on decaying DC component, because if you perform switching action at t equal to 0, let's say this particular one at t equal to 0 you perform switching action. So let's say this was your steady state current without any transient, but and this is your steady state current without transient. But since there is a transient, what will happen? And this particular graph will shifted like that, it will come, and this is coming because of this decaying DC component, and these two component will get added, and it will start from 0, and slowly it will settle down at steady state. Okay. In this question they asked, we don't want any kind of AC, so any kind of DC transient. So there will not be DC component in this question. You can see there is no DC component. It is taking from this point of view, it is purely sinusoidal. Okay. Yeah, from this discussion, if you have any doubt, you can ask me in the chat box. Thank you.